Section 1.1 is just about graphing different function and techniques when you're graphing. For example, if somebody comes in and says, can you graph y equals 7 minus 3x? Now, one of the ways to graph things is really by what? Picking points. Making a table. And you can choose any values for x. You can use any number you want to. You say, you know what? I didn't have anything to eat today. I'll use 0. I had 1 cup of coffee. I'll use 1. I don't smoke, but let's say you're a smoker. So I smoke 4 cigarettes today. I'll use 4. So you can choose any number. Just make sure they're reasonable numbers. So you pick these numbers, then you want to calculate or compute the y value. Well, how do you compute the y value? Well, when x is 0, what is y?
7.
Yep, 7 minus, you replace x with 0. 3 times 0 is 0. That's 7 minus 0, which is what? 7. When x is 1, y is what? 7 minus 3 times 1. 3 times 1, remember, order of operation, you do the multiplication first. 3 times 1, you got to do that first. That's a 3. And 7 minus 3, which is what? 4. When x is 4, y equals what? 7 minus 3 times 4. Again, the multiplication first. 3 times 4, which is what? 12. 7 minus 12, which is negative 5. You can pick as many points as you want to. We know this is a linear equation. Linear, the graph is going to be a straight line. So you don't need more than 2 points actually to graph it. I chose 3 just to be on the safe side. So here we go. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 6, 7, 8, 9, 10. And I can go in this direction again. Seven, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now I'll start finding the points. 0, comma 7. Where is 0, comma 7? 1, 2, 3, 4, 5, 6, 7. That's right here. 1, comma 4. That's 1, comma 4. And 4 and negative 5. 1, 2, 3, 4, and 5 down. 1, 2, 3, 4, 5. Somewhere here. You get the 3 points. They should make a straight line. If they don't make a straight line, make the dots really big. Then you get a straight line. And that's your graph. 7 minus 3x. When you have a straight line, it's not bad. 2 or 3 points, you can graph it. But if it's not a straight line, you might be there for half an hour trying to pick all these points. You know, in Calc 1, when we get to Chapter 4, one of the applications for derivative is it helps us graph a function without having to pick 10,000 points. We'll get to that later, but for now, you really not much of a choice except picking points and graphing that and finding the x-intercept, finding the y-intercept, you know, finding the domain, see which one looks like the domain for this. Can we use any x value for this and get an answer for it? Is there a number that if I plug it in, there's no answer to that here? No. So my domain here is really x such that x belongs to R. all real numbers. And if you look at the graph that when we did, my range is the y value. And you can see the y value starts from down here, way in the bottom, which is negative infinity, all the way to where? To infinity. So again, you can say y, depends how you want to write it, between negative infinity to positive infinity. Or if you want to write that in interval notation, from negative infinity to positive infinity. Notice I use parentheses, not a square bracket. Why? Parentheses means the point is not included. Infinity will never be included, plus or minus, because you can't reach them. Now, if you get a crazy function, it's not a straight line, then you got to pick a lot of points. Like, I'll slow it down a little bit. I'll drink more coffee to get me going. Woohoo! Let's say I have this, y equals, I don't know, let's do x cubed minus 4x. Now to graph that, that's not going to be quickly. I got to pick a lot of points. I better make the line big here. X versus y. I'll start with some positive numbers, negative numbers like 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. It's not a straight line. It's x cubed. Yeah, it might have actually 2 humps in it, up to 2 humps. So you better pick a lot of points. So when x is 6, it's going to be a big number. So where's my calculator? We can cheat here. We know how to do simple math, so I'm just going to cheat here. I'm going to go to table set on mine. Is that where I want to go? Second table, let me just see here. Okay. Let me type in the function. Y equals x cubed. What is x? X to the power 3 minus 4x. And I'm going to graph that. Let's go to table here. And let me try 6. When x is 6, what's the y value? 192. I'm cheating here. You can plug it in. When x is 5, the answer is what? 105. When x is 4, it's 48. When x is 3, it's 15. When x is 2, is 0. When x is 1, is negative 3. When x is 0, that's a 0. When x is negative 1, love calculators. Is that a 3? Yep. When x is negative 2, that's a 0. When x is negative 3, that's a negative 15. Negative 4, negative 48. Well, it looks like symmetric to that one, right? Negative 105, negative 1. I'm taking a wild guess, but I can test them. Yep. Yep. So I kind of cheated. I went to my calculator and I typed in the equation just like I was about to graph it. Then I went to table. And once you get to table, you can start putting your own numbers, any number you want to. The problem is you can't put a decimal value. I did and it took it. That's because on my calculator I did table set. Where is that? And I went to ask mode instead of auto mode. Usually when you go to mode is automatic. It's always a whole number. By changing that to ask mode, can you see it? I can put any number, decimal number, anything I want to put there. So you go second table set, which is right here. And you get to this menu and make sure that independent variable, that's X, is in the ask mode. And leave the other one in the auto mode, which means compute that for me. This way you can put any decimal number you want to. If I put it in auto mode, you can only use whole numbers.
It's not quite true.
Huh?
It's not quite true. You can change the
step?
Yeah.
The table setting by 1. I have mine by 1, so I was going to go by 1. But you can make it by point when it goes 3.1, 3.2, 3.3. I want to do 3.15. Then I got to come back and change it. So go to ask mode, then you can put any number you want to. Quit, get out of this. Where's quit? Where'd you go quit? There we go. So that's one way to do it. If I go to graph this, well, the first group of numbers are silly. Unless I have a step ladder, I'm not going to be able to graph that. So what I might do here, fudge things up there. I'll skip the first 3 here. I go, too big of a number. I'm not going to do it. When X is 3 is 15. 15 is somewhere here. When X is 2, that's a 0. When X is 1, that's a negative 3. When X is 0, that's a 0. When X is negative 1, that's a 3. When X is negative 2, that's a 0. When X is negative 3, that's a negative 15. Somewhere here. So now you can't connect them with the straight line. Any way you slice it, it's not going to work. The graph looks something like this. And it keeps going. It doesn't stop here. I just decided to quit after 3 points or 6 points. But these I wasn't using. I will need a huge piece of paper to be able to graph these. So that's what the graph will look like. Now these points here have a name. Those are the x-intercept. And this point also is what? The y-intercept, the origin. You can find the x and y-intercept because sometimes these values not exactly on the money there. It's not negative 2, 0, and 2 there. So how do you find the x-intercept and the y-intercept? Perfect. So in case you didn't hear him, it says to find the x-intercept, you set y equals to 0 and solve for x. And to find the y-intercept, you set x equals to 0 and solve for y. You saw on the first homework assignment, we said which one of these looks like the graph. I could have just looked at the x-intercept and see if they match this one. If they don't match, that's not the answer. So sometimes you don't have to graph it to see which one is the right answer. If you have a 3x intercept, one has 1, one has 2, one has 3, most likely the one with the 3 is going to be the correct answer. And see if they line up where they're supposed to be. So if I take this one, we know where the x-intercept are. We get the 3 points right here. I want to see if the math will give me the same 3 points. So y equals, what was it, x cubed minus 4x. Let's do the x-intercept. And let's do the y-intercept. So the x-intercept, what do? Set y equals to 0. So 0 equals what? X cubed minus 4x. How do we solve this for x? What do? Factor, absolutely. Notice you can factor an x out. If you factor an x out, what's left? X squared minus 4. Can you factor x squared minus 4? Yep, that's x minus 2, x plus 2. You set each factor equal to 0 and solve it. So x equals to 0, that's one of them. X minus 2 equals 0, which means x equals 2. That's another one. X plus 2 is equal to 0, which means x equals negative 2. So we have 3 x-intercept. 0, 0, negative 2, 0, and 2 and 0. I like to write them as an order pair, x and y. So these are my x-intercept. I get 3 of them. How do you find the y-intercept? You set x equals to 0. If you set x equals to 0, you're done. That's it. Nice one. So that's 0, comma 0. That's my y-intercept. That's my x-intercept. The 0, 0 happens to be both x-intercept and y-intercept. So you can look at this graph and see if it matches. You go, do I have 3 points that cross right there? Yes. And there's a good chance that's going to be my answer. So sometimes by knowing the x and the y-intercept, you can really zoom in on the answer without having to graph it. The other thing we use sometimes is symmetry. We check to see if the function is symmetric. Symmetric with respect to the x-axis, symmetric with respect to the y-axis, and symmetric with respect to the origin. This function is symmetric with respect to the origin. So let's look at that, symmetry. Let's look at symmetric with respect to the y-axis. Can everyone see the writing on the screen? Should I make it bigger? Yes.
Just out of curiosity, does that record your voice?
Yes. So later I will take these and put them on YouTube. So your voice also going to be on the lecture now. Yep. If the FBI is looking for you, you're in trouble. Symmetric with respect to the y-axis. What does that mean? Why you want to know that? Because if you know what the graph on one side, if you know the function is symmetric with respect to the y-axis, you don't have to pick points on both sides. If you know this side looks like this when you pick the positive value, then what's the other side going to look like? It's going to look like this. So you only have to pick points on one half of the graph. And so in the previous one, if I known that was symmetric with respect to the origin, this one here, notice I only have to graph this side, pick these points, and by knowing the graph on this side, I can tell you exactly what that picture is going to look like. So how do we know the function is symmetric with respect to the y-axis? Well, replace x with negative x. What does that mean? If you replace x with negative x, you still end up with the same expression. The function is symmetric with respect to the y-axis. So a lot of times you'll see us write this: f of negative x equals f of x. For example, quadratic parabola, y equals x squared. This function is symmetric with respect to the y-axis. Why? Because if you replace x, what's f of negative x? Replace x with negative x. This will be a negative x squared. And what happens when you square a negative sign? Comes a plus. Is that the same as this? Yes, because f of x was x squared. So this is symmetric with respect to the y-axis. It has another name for this. Anyone? That's known as even function. You hear that once in a while. If the function is an even function, that means symmetric with respect to the y-axis. If you took pre-calc, you probably heard that even, odd, you know. Even function, the function is symmetric with respect to the y-axis. Again, what's the purpose of knowing symmetric? Now if I want to graph this, I only have to graph one side of it. X versus y, 0, 1, 2, 3. That's it. I don't have to use any negative numbers, because whatever the graph on the right side looks like is going to be identical on the left side. So when x is 0, let's plug it in. What is 0 squared? 0. When x is 1, what's 1 squared? 1. When x is 2, what's 2 squared? 4. When x is 3, what's 3 squared? 9. No negative values. I don't need them. If you pick these points, you notice the graph looks like this. Since we know it's symmetric with respect to the y-axis, what is the other half going to look like? Identical to this. It's going to look like this. So instead of picking 8 points or 10 points, I can shrink it to 4 points, 5 points, 3 points. And I have a good picture, good idea if that function is actually looks like this or not, by knowing if it's symmetric with respect to the y-axis. So that's how we test if the function is symmetric with respect to the y-axis. How do we test to see if it's symmetric with respect to the x-axis? I was careful saying that, because I said we know if the function is symmetric with respect to the y-axis. Is this a function? Is the graph of this a function? How do you know you have a function? How do we test to see if you have a function or not? Vertical line test, absolutely. You draw a vertical line, and if any of the lines intersect the graph at more than 1 point, it's not a function. So notice, vertical line test, all these intersect the graph at how many points? 1. This is a function. I said I was careful with the other one. Symmetric with respect to the x-axis is not a function. But it could be, the equation or the graph could be symmetric, but it's not called a function. Again, what that means, if we know what one side looks like, let's go back to this one. Let's say this is the graph here. If it's symmetric with respect to the x-axis, what is the other half going to look like? It's going to look like this, right? Now, is this a function using the vertical line test? No. That's not a function. Because to be a function, what is the purpose of the vertical line test? It says to be a function, for every x value, there's one and only one y value. This x value has how many y values? 2. One here and one here. That's why that's not a function. So it's not a function, but we can still graph something, an equation, an expression, even if it's not a function. How do we test to see if that's an odd one? Oh, that's not an odd, I'm sorry. Odd is symmetric with respect to the origin. How do we test to see if that's symmetric with respect to the y-axis or x-axis? Respect to the x-axis. What do? Replace what? Replace y with negative y. Now you could have an expression that looks like this: x equals y squared minus 3. Now replace y with negative y. Let's see if you end up with the same expression. X equals negative y squared minus 3. And what happens? Are these two the same? It is symmetric with respect to the x-axis. When you have x equals y squared minus 3, your independent variable is really y, and your dependent value is x. X depends on the value of y. That's where the name came from. So when you're making your chart, you're going to pick values for y, not for x. We're going to choose values for y and find the x value. When y is 0, what is 0 squared minus 3? Is that a negative 3? So x is negative 3. When y is 1, 1 squared minus 3. What's 1 squared? 1. Minus 3 is what? Negative 2. 2 squared minus 3. 4. 4 minus 3? 1. 3 squared minus 3. 9 minus 3? 6. Let's see if that looks like what the graph looks like. We know it's symmetric with respect to the x-axis. So negative 3 and 0. Negative 2 and 1. 1 and 2. 6 and 3. The graph looks like this. Since it's symmetric with respect to the x-axis, what does the other half looks like? I'll have to do half of it. So this is symmetric with respect to the x-axis. There's no name for it. It's not an odd function, because this is not a function. We have even function, odd function. Even function is the previous one, symmetric with respect to the y-axis. That's an even function. So what is an odd function then? It's not this one. Still a function. That's symmetric with respect to the origin. Okay. What does that mean, symmetric with respect to the origin? Again, if you know one piece of the graph, one side, you can find the other one. So again, let's go back, assume this side looks like this. And we know it's symmetric with respect to the origin. I really don't have a good imagination. I have a simple mind. So to do that, I found out what works for me. I gotta cheat a little bit there. Do a step in between, because I don't have that imagination. To find what the other half looks like, you have an option. I'll do it both ways. You can either do it with respect, flip it, make it symmetric with respect to the y-axis. If you do that, notice I'm using a pencil, it will look like this. So flip it over the y-axis, then flip it over the x-axis. So if you flip this one over the x-axis now, this one here, what is the picture going to look like? Going to look like that. So now you can go back and erase this. That's just step in between. Or it's two flips, so it doesn't matter which one you do first. You could have done it with respect to the x-axis first. If you did that, it will look like this. Then when you get that one, you flip it over, you end up with that piece. So that's how you find what the other half is going to look like. You got to flip it twice. Once over x, once over y. You flip it over x, you take the new picture, flip it over y. Or flip it over y, take the new picture, flip it over x. You get the second half. How do you know the function is symmetric with respect to the origin? Two things. Replace x with negative x and replace y with negative y. If you end up with the same expression, you have a function. Notice that's still a function. And by the way, that's called odd function. Remember we had even function? This is odd function. When you hear the word odd function, that means symmetric with respect to the origin. Still a function, vertical line test, because this is just a step in between. It's not there. So you can erase it. So the vertical line test only intersect the graph, each one of them at one point. Boom, 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 boom. A lot of times you see us write this, f of negative x equals negative f of x. It's the same thing. Replace x with negative x, replace y with negative y. That's really the same thing. Let's take that function because that looks like it is symmetric with respect to the origin. The one we did early. This one. Y equals x cubed minus 4x. Replace x with negative x and y with negative y. Let's see if you end up with the same expression. I'm replacing x with negative x. I'm replacing y with negative y. When you take negative and you cube it, that's still negative. And this will be negative, negative, positive. And to solve it for y, we're going to divide or multiply by what? Negative 1. If you multiply everything by negative 1, you end up with y equals what? X cubed minus 4x. Is that the same as what you started with? That is an odd function. Again, I only have to graph 2 or 3 points on the right side, flip it over, I have the left side. 0, 1, 2, 3. That's all I need. Few points. When x is 0, what is 0 cubed minus 4 times 0? That looks like a 0. When x is 1, what's 1 cubed minus 4 times 1? 1 cubed is 1, that's a negative 4. What's 1 minus 4? Negative 3, okay. When x is 2, what is 2 cubed minus 4 times 2? 2 cubed is 8, that's 8. What's 8 minus 8? 0. When x is 3, what is 3 cubed minus 4 times 3? 3 cubed is 27. 27 minus 12 is what, 15? Again, you graph 1/2 of it, 0, 0, 1 and negative 3, 2 and 0, 3 and 15, and somewhere there it looks like this. Remember, this is symmetric with respect to the origin. You gotta flip it twice to get the final picture. Doesn't matter which one you do it first. So here's my pencil. I'll go around the y-axis first. If I do the y-axis, it looks like this. A bit deeper, actually. Now we take this and flip it over the x-axis. What are you going to have? Like that. Wasn't that the picture when we graphed it before? Now I can take my pencil, erase that step in between. And that's what the graph looks like. So just little techniques to speed up the process. Instead of picking 10,000 points, if you know it's odd, even, you can graph one side, flip it over, and you have the other side. That's really the advantage of that.